Assalamualaikum and hi. Today, my group members and I would like to present about application of differentiation from Calculus 1. Let me introduce myself first. My name is Alya Afifah and this is my group members, which is Nawwarah Hana, Balqis Nur Aqilah, Sara Emelin and last Aminah Najihah. So, let's begin. Okay, so firstly, we have to know what is differentiation actually. Differentiation is a process of finding the derivative or rate of change of the function. Next, in the mathematics term, the derivative shows that sensitivity of change of a function output with respect to the input. The derivative also are a fundamental tools of calculus. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve.
Analysis of function. There are two types of analysis of function: polynomial function and rational function. How to solve the polynomial function equation? There are 6 steps that have to remember. First, find the x-intercept and y-intercept of fx. Second, find the critical points of fx. Third, find the intervals where fx is increasing or decreasing. Fourth, determine the relative extremum point. Fifth, find the intervals where the fx is concave up or concave down. Sixth, determine the inflection point. And the last one, sketch the graph of fx. The equation given a function of fx equals to x cubed plus 4x squared minus 3x minus 18. Step 1. Find x-intercept and y-intercept. If you want to find x-intercept, let fx equals to 0. Substitute x with 0 and solve it using a calculator. You will get x equals to 2 and x equals to negative 3. So x-intercept equals to 2, 0 and negative 3, 0. For the y-intercept, let x equals to 0. Same like x-intercept, substitute x with 0. Then you will get negative 18. Y-intercept equals to 0, negative 18. Step 2. Find critical point. To find the critical point, you need to differentiate fx to get f prime x. And then let f prime x equals to 0. Solve it using a calculator and you will get x equals to 1 over 3 and x equals to negative 3. And then, next, to get the coordinate of y, you need to substitute x equals to 1 over 3 and x equals to negative 3 into the fx equation. And then the critical point, you will get 1 over 3, negative 500 over 27 and negative 3, 0. That's all.
For step 3, find interval increasing or decreasing. We're going to use the same function, which is x power of 3 plus 4x power of 2 negative 3x minus 18. So we're going to factorize it and we get negative 3 and 1 over 3. So for the interval, we will use negative infinity, negative 3, negative 3, 1 over 3, 1 over 3 infinity. So this is for the interval. And then test value, we will use negative 4 because it is in the, for the first test value, we will use negative 4 because it is in the range negative infinity, negative 3. For the second test value, we will use 0 because it is in the range negative 3, 1 over 3. For the third test value, we will use 1 because it is in the range 1 over 3 infinity. So, what we're going to do is, we're going to key in this test value into the function and see whether we got positive or negative number. So if we got positive number, it is increasing. So if we got negative number, it is decreasing. So for the first interval, we got positive number, which is increasing. For the second, we got negative number, which is decreasing. For the third, we got positive number, which is increasing. So we have two interval increasing here, which is negative infinity, negative 3 union with 1 over 3 infinity. For interval decreasing, it is negative 3, 1 over 3. For step 4, find the extremum point. We will use the same function, x power of 3 plus 4x power of 2 negative 3x negative 18. And then we will key in the factors, into the function. So for the factors -3, we get 0. And then for the function 1/3, for the factors 1/3, we get -18.5185. So the maximum point is -3, 0, and for the minimum point is 1/3, -18.5185. So for step 5, we will find the interval concave up or concave down. So we will use the function second derivative, which is 6x plus 8. We will use that function. So to get the factor, we will equal 6x plus 8 equals to 0, and then we will get x equals to -4/3. So what we will do here is we will do the table, interval and test value. So for the interval, we will use -∞, -4/3, -4/3 infinity. So the first test value we choose -2, the second test value we choose 0. So if we got negative number, it will be concave down. If we got positive number, it will be concave up. So for the first interval, we got negative number, which is concave down, and then the second interval, we got positive number, which is concave up. So for interval concave up, it is -4/3 infinity. For concave down, we got -∞, -4/3. For step 6, we will find the inflection point. So what we need to do is we need to find the second derivative, which is we already find it, 6x plus 8. So what we need to do is we need to equals the 6x plus 8 equals to 0, and then we will get x equals to -4/3. After that, we will substitute -4/3 into the real function, which is 3x power of 3 plus 4x power of 2 minus 3x minus 18. And then after we substitute the -4/3, we get -9.259. So the conclusion is the inflection point was -4/3, -9.259. So for step 7, graph of function x power of 3 plus 4x power of 2 minus 3x minus 18. So we just going to key in this function into symbol lab, and then we will going to label it. So we have two x intercept. So the first x intercept is -3, 0, which is also maximum point. And then the second x-intercept is 2, 0. And then y-intercept is 0, -18. Also minimum point is 0.33 and -18.519. That is a minimum point.
So this is how to solve rotational function question. There are 6 steps to remember. First, you need to make sure the equation is in the form of fx equal to px over qx. Second, find the x-intercept and y-intercept of fx. Third, find the vertical asymptote and horizontal asymptote. 4. Determine the interval where the function is decreasing or decreasing. 5. Determine the interval where the function concave up or concave down. And the last one is sketch the graph of fx. So, given the function here is fx equal to 3x plus 1 over 2x plus 3. First, you need to find the x-intercept and y-intercept. To find x-intercept, you must let fx equal to 0, and then you will get x equal to -1 over 3. To find y-intercept, let x equal to 0, and you will get x-intercept equal to -1 over 3, 0, and y-intercept is 0, 1 over 3. Step 2. You need to find vertical asymptote and horizontal asymptote.
vertical asymptote, you need to let Qx equal to 0. So you will get x equal to -3/2. So this is the analysis of vertical asymptote. Lim fx equal to lim 3x plus 1 over 2x plus 3, where the limit is x greater than -3/2. So you will get negative infinity. For the limit x greater than -3/2, you will get positive infinity. So the vertical asymptote here is -3/2. Then to find horizontal asymptote, this is the limit is x greater than plus minus infinity 3x plus 1 over 2x plus 3. So after the calculation, you will get 3/2. So the horizontal asymptote here is 3/2. For step 3, you need to find interval increasing or decreasing. Here, you have to differentiate the function, and then you will get 7 over 2x plus 3 squared. For interval negative infinity, -3/2, the test value is -1.6. So you will get interval increasing. For interval -3/2 and positive infinity, the test value is -1.4. Then you will get the interval is increasing. So the interval increasing here is negative infinity, -3/2, union with -3/2 and positive infinity. Interval decreasing here is none of it.
Okay, next, to find interval concave up and concave down, we must differentiate fx twice, that known as the second derivative. So first, we need to bring 2x plus 3 power of 2 upward. Then it become x7 multiply 2x plus 3 power of -2. Then we bring power of -2 into in front and multiply with 7. Then copy from the bracket. Then the power must be to -1. Then we need to differentiate from the bracket, so we get 2 and multiply 2 with 7 and -2 that we bring in front just now. At last, we will get f double prime x equal to -28 divided by 2x plus 3 power of 3. Then we need to draw a table. So divide by 3 columns: SE interval, test value, and f double prime x is equal to -28 divided by 2x plus 3 power of 3. Then the interval is a negative infinity to -3/2 and -3/2 to infinity. The test value is -1.6 and -1.4, and we will get the interval for -infinity and to -3/2 as a positive value, and it labeled as a concave up. Then for interval -3/2 to infinity, to positive infinity, we will get negative value, so it called as a concave down. For the conclusion, is concave up is a negative infinity to -3/2, and concave down is a -3/2 to infinity. So based on the graph conversion of fx equal to 3x plus 1 divided by 2x plus 3, we will get the x-intercept is a -130 and y-intercept is 1/3, and positive infinity as a concave up and negative infinity is concave down, and vertical asymptote and horizontal asymptote that shows on the graph. So for the conclusion, From these types of solution, we can conclude that we can find or determine concavity of function fx by doing the second derivative of fx. Other than that, we can know whether the concavity is concave up or concave down. So that's all from us. Goodbye and thank you.